So when you say H2O, it's not a right or a wrong answer, you know. It's just a question you're going to tell me your opinion about. Why you say H2O?
Sir, I was wrong, sir.
You was wrong. Who told you that you were wrong? Nobody told you that you were wrong. So why did you say H2O?
Sir, I was looking at the H and the two in front of the H and the O, sir.
So nothing
You
is wrong with
understand?
that. Nothing is wrong with that. You're telling me then that
But I actually misplaced the two
you
after
know
the
me see it's
oxygen.
not me ask you one simple question and you go to part D and E. We don't ask you that. We just ask you what you expect to happen. All right. If
Sir,
you yes, go ahead.
hydrogen peroxide.
No, we ask you what go happen. We never ask you what go farm. What will
Oh,
happen? What will happen? Not what will be farm. What will be farm is like you're making me should look hard. Me ask you what go happen. All right, me ask you this then. Hydrogen is over here, so oxygen is over here, so right?
Some kind of reaction.
Well, then when you react. All right, so what happens? How them going to react then? This is basic stuff. If you have two elements, one minding its own business, the other minding its own business, they come together. What's going to happen?
Name probably bond.
Them ban. So you're going to ban. That is the word they need to use. All right, so you don't need to go all advanced to talk about compounds where we don't even know if it's a go farm because really and truly, you have more than one compounds that these two can make. Right, so the point is, what is going to happen is that they will combine or they will bond. That's what I was looking for. Everybody get that?
Yes.
So they will band together. No, they will band together. We know what banding is. Right? They will band together. So
Probably a covalent.
probably. Probably. Because this is the direction I want you guys to understand what's happening here. So there we have our H. Two H's, by the way, because see the equation say H2, so it's really two H's. But you see that?
Yes.
All right. Then now we're adding O. All right. And O should be a bigger atom. But well, let's just throw caution into the wind here. And use the symbols that they have here. And then I have to go remove the fill. And say no fill. And use that. All right. It's gonna be a little bit bigger. All right. And so you say it's gonna bond, it's gonna combine. But here's the thing now. I'm teaching about oxidation. So what does this have to do with oxidation? Well,
Sir,
oxidation.
when I go lose, sir, when I go lose, one to get, and I don't wanna gain. When I
Well,
go oxidize, I wanna go reduce, reduce.
very good point there. One will lose, one will gain. But which one will gain? Which one will lose?
The hydrogen, sir.
The hydrogen. All right. You see, that's why I like this exam. The exam is gonna test the knowledge of basic things. See the hydrogen is gonna gain. But there's an easy way for us to know. Do we know where hydrogen and oxygen is on the periodic table?
Yes, sir.
Yes, sir.
Where is oxygen?
Is in period two, group two, period two.
All right, tell me in terms of left or right. Where is it? Left or right?
I think it's kind of
Right.
more to the
To the right? I say right?
Yes, sir.
I
All
would
right,
say
well, yeah. You say right. Mm.
My right. Me no know. My right, sir.
Yes.
You're
my
right. If you're
yes.
right, then right. So stick with that then.
Right.
So,
Right to
all right. Let's show you this then. All right. I'm gonna show you something, and this is I think this is the term that a term that people tend to overlook here. All right, let's bring this up. All right, now have a look at this diagram then. I'll show you something. It's
yes,
all right.
in period two.
All right, so we notice that and this, what is that word that is the title of this diagram?
Electronegativity.
All right, anybody know what electronegativity is?
Negative electrons. Just guessing, sir.
That would be a redundant, would it be? Negative electrons? Well, no, you have positive electrons, so yeah, get away there. But no, it means something about electrons, yes. But what about electrons?
Negative. You have to do something negative, sir.
Right.
Negative.
Let's clarify this then. Tendency.
Negatively charged.
Well, that's a better way to say it. Yeah. Tendency of an element to gain electrons. Or tendency of an atom or element to gain electrons. So you see that to gain this is so they have a number here. All right. So they have a number here. You know, you realize that everything that is on the right hand side, that's where I asked you where oxygen was. If you know where it is, then you can have an idea of what it's gonna do. Where it is, you know, we tell you what it's gonna do. So it's just like if maybe, you know, maybe a person come from a bad place, you're gonna probably figure say he's a bad person. Oxygen comes from a place in the periodic table where these elements just love to gain electrons. They love to pull in electrons. Reason for that, the atoms are small, and then they have like, they just need like one or two to fill up them shells. So they're going to be pulling on those electrons. So if we go back to this diagram, we see that oxygen has 6, and it would need how many more? All right. And the question you're going to ask, how much would this oxygen need to have a stable outer shell?
Oxygen need 2.
Yes, I need 2. So realize that here's 2 hydrogen here.
Yes, sir.
So now then you're gonna say, but sorry, you know, they will say when 2 non-metal react, you're gonna get covalent bond into more shear. Well, yeah, the more shear, but then you have different types of covalent bond. Now we have the normal covalent bond, which is what we call non-polar, and we have the polar covalent. Yes, the one where one of the atom, even though they are sharing, one of the atom holds on to the electrons more than the other. So in this case now, because oxygen come from the bad side of the periodic table where them just, you know, steal electrons. And that is why oxygen is seen as an oxidizing agent, because what? Oxidation is one of the definitions you learn is that what? It's the loss of electrons, right? So and then when something is stolen, you're going to ask who do it. No, so if you
Yes.
something stolen from you, your money or whatever, your price possessions, your phone, you know, all right, it was here a while ago and then you go back, it's not here. So somebody must steal it. So when you ask yourself who do it, that's when the answer would be the oxidizing agent. So I hope everybody understand that. All right. Why the name oxidation came in the first place was because of this element oxygen. All right. It was discovered by the name of Antoine Lavoisier from France, actually, back in 18th century. He discovered this. By the way, only to have his head cut off a few years after. Sad though. Anyway, but all right, so he discovered this. And the long and short of it is that oxidation is, yes, the loss of electrons, but that's not the only definition. When we look at what oxidation also mean, let's go to the other definitions here. We would say oxidation is the loss of electrons, but it's also a simpler one, the addition of oxygen to a substance. All right, so that's the second definition for oxidation, the addition of oxygen to a substance. All right, so oxidation is one, loss of electrons. Everybody know that. Two,
Yeah.
yes, addition of oxygen. Why? Because when you add oxygen to something, it's going to lose electrons. Everybody see that?
Yes, sir. Yes.
Because oxygen is a thief. Right, and not only oxygen alone. In the periodic table, these thieving elements, you have chlorine as well, which look at the number that it have, right? So it means this 3.5. Yeah, the most you can have is 4, Fluorine is the most, you just say the most crooked element then. Right? It's gonna steal the most electrons. And that's fluorine. And you see that red sign that show danger. So oxygen is not so red, 3.5, and then chlorine is 3.0. Nitrogen is there also at 3.0. So these elements in compound, guys, especially in organic compounds, oxygen will hold on to electrons. So even though it will be covalent, oxygen still going to dominate the sharing. All right, so that's basically it. Any questions here, students?
No, sir.
And I hope you guys understanding and you're there. Casey, you there?
Yes, sir.
Hope you didn't go for a break a while ago, and right,
No.
sound like you're running back from somewhere. All right. Kimberly, you there?
Yes, sir.
Dear Chanel, you there? You see, Dear Chanel gonna sleep. You see your answer so low, and also your sound, As so you normally sound. You do something. You
I
see?
wasn't doing anything, sir.
All right. So we'll see. We'll see when the time comes. You'll be getting tests and those things at the workshops coming up soon. So we'll see. All right. Trust that Benito is there. Shanta, you there?
Yes, sir.
Yeah, good. Yeah. So answer strong this. All right. Daniel.
Yes, sir.
You sound like you there or something else. Where you're texting.
No, sir, I'm just tired, but I'm here.
Okay. Just hang on. All right. You can manage. All right. Michaela, you there?
Yes, sir.
Okay. That's nice. All right, Deborah.
Yes, sir.
All right, Deborah. So, all right. So as we say, based on the behavior of oxygen and how it's going to react with other compounds, the other definition for oxidation is that it's the addition of oxygen to a substance. Remember, say 4 of them we say we have, all right. What's the third definition for oxidation? Mm. All right, it's the third definition. So the reason why I use these two elements. Let's go back to that chart I showed you. You realize that oxygen is way over here, so on the right hand side, right? That'll be my right hand side, probably your right hand side too. So the right hand
Yes,
side of the
sir.
period table, yeah. So remember that over here, so I'll be your teeth come from here. So now the opposite of stealing is what?
Caring, sharing.
All right, if you don't take something, what's the opposite of taking away something?
Receiving.
Receiving.
Giving.
Giving.
Yeah, cause when you take, you receive. You receive in our illegal way, you know. So yes, giving is a better word here. And so because hydrogen is way over here, so on this side, hydrogen has a giving sort of behavior in chemistry where it has one electron, yes. It just need one more, but oxygen and fluorine and these elements are much better at getting these electrons away from other substances. So hydrogen tends to just hover around, and all right, you say if there's a oxygen there and oxygen want the electron, then you just give it to it. And that's why oxygen, if you notice the formula of water, we talk about, anybody remember the formula of water?
Yes, sir.
What's that?
H2O.
All right, if you say H2O, notice that in this formula here, one oxygen is actually taking the whole of two hydrogen. That's strong. All right, that's a very strong thing there. So oxygen has that ability to pull in. So now, throughout chemistry, because they're on opposite sides of the periodic table, we say that we treat hydrogen as like the opposite of oxygen. So that's why even when we're doing acid and bases, when oxygen and hydrogen meet up, we say, well, it neutralizes. All right. In oxidation and reduction, we say, well, if a substance gain oxygen, then it has been oxidized. But there comes our third definition for oxidation now. The opposite of adding oxygen is actually this, right? It's actually this. All right. So I don't know if you've ever seen these definitions before for oxidation, but these are actually three definitions for oxidation. I think there's a fourth one, not sure, but when it comes up, I just mention it. But the point I'm trying to get to is that when I ask about oxidizing agent, don't just get fixed on the loss of electrons. Yes, that is true, but there's more to it. All right. So all right, everybody knows that, all right, the fastest woman alive now is Shelly-Ann Fraser, but there's more to it. Her training, or her fitness, all of that sort of thing. So the wind as well. So that could be blowing when she's running. So all of these things. So don't just be focused on the one thing that everybody talk about. Try to find out why it is so. You're going to stand out from the crowd that way. All right, because CXC knows everybody in the Caribbean doing chemistry. Once them go in a pharma class, them bound to know that oxidation is a loss of electrons. But what they forget now is that I can look at a reaction without seeing any electrons, because when I go back to this question, there are no electrons here. This question here. This question is here. Yeah, you see, there are no electrons shown here. So yet this question asks, what is the role of potassium dichromate? Didn't even call the name of it. They write the formula and expect you to know it. So, all right. But then, so we established that it's an oxidizing agent. Fine. Bam. But then when I went on to ask, what happens now when this reacts with the alcohol, you're gonna say, all right, it oxidizes it, but and then no, General was saying what? Lots of electrons, so fine, but that's still not telling me the full story. All right. What is taking away the electrons? That's the question. What is taking away the electrons? All right. Because that is the question. So potassium dichromate here has 7 oxygen atoms, which means there are 7 criminal are going to introduce to the compound now. Right? And when one of those criminals now decides it will go attack the alcohol, notice that it's going to attack the carbon. And with good reason, because well, this oxygen already have a hydrogen, so it's not trouble that. So you trouble this carbon here, whatever was there, it will go basically take away the electrons where the carbon did have here. Notice that carbon is in. Anybody remember what group carbon is in? What group carbon is in? But let me put it this way. How many electrons does carbon have on the outer shell? How many electrons?
Carbon.
Yes, carbon.
Sir, I was just going to say about
4, sir.
4. Thank you very much. That's so nice. Chanel. Yeah.
Yes.
All right. Yeah. So it's 4. So then you don't see what happened then. All right. So what happened here? So no. Bam. Let's take off that. All right. Take off this. I will take off this too. I will take off that. All right. Yeah. Take off that. Carbon of 4. So one of the carbon then. So basically this is what's happening. When I carry this one of this here, this potassium dichromate, I'm introducing oxygen to what was there before. So, all right, if we just select this, let's see if we can get what was there before. And so something like that was there before. All right, some alcohol. I know say alcohol end with OH. All right, I'm gonna move that. Some alcohol end with OH. So then all right, let's put back the people in question, because as CXC probably watching this online. Let's see why I'm messing with them question. All right, sorry CXC, just I'll show them something. All right, let's get this out of the way. There you go. All right, and so I want to put back the compound and show you what was there before. So before them 2 electrons were robbed, the compound to the left was there. And so that's pretty much the second definition for oxidation. What does the second definition for oxidation state?
the loss of oxygen, addition of oxygen.
The addition of oxygen. And we're seeing that with the alcohol, we just add oxygen to it and it becomes something else. It becomes something else. The question is, what does it become? That's the alcohol label D. All right, let's fix up this card. What does it become? When you oxidize an alcohol, when you oxidize an alcohol, what does it become? You did this already, no? This already, but to not have life too easy. So on do that F thing we wanna do all the time. That forgetfulness. Right?
When you oxidize,
when you oxidize an alcohol, what does it form?
Aldehydes.
All right. Getting somewhere. You say aldehydes. Interesting. So but then when we look at it, aldehydes, even though aldehydes is another functional group, is it that is aldehydes one of the compounds that we are supposed to know about? No. So what's the next step then? Because we did say aldehydes are an intermediate compound, because that's like a true road then, you know. It's like that's like actually passing through like Mapping to go into Kingston. So you really want to go Kingston.
Carboxylic acid.
Yeah, that's a better answer. That's what we're going after. All right. So in CXC, guys, whenever we oxidize an alcohol, the compound we're looking to be formed is the carboxylic acid. All right. So, all right, oxidation of alcohol. So, and again, CXC has specifically said that they're going to send you reactions of carbon compounds. You don't know which one. Could be the alcohols. One of the most likely ones, because students tend to not know that. Let me see something here. I'm trying to find some visual for you guys to see what happens when those two things react. But unfortunately, persons seem to want to make chemistry look hard. So sad. Anyway, find something. Or find something ish. All right. No. So we're not use it. So all right, do it my way. All right. So then, so what we have here, alcohol. So again, we're going to leave class with this information. This information is crucial. Whenever we have any alcohol and you're a CXC student that is adding sorry. No, I was actually thinking about a different compound. All right, so we have an alcohol, any alcohol, and we'll add this substance to it. All right, it is going to be K2CR2O7. What did we say the name of this was again?
Potassium dichromate.
All right. All right, and by the way, it should be acidified, but then let's leave that because we don't want to complicate that issue there. Upload pending. All right, like something is happening, like probably running out of space or something. Let me see something. It's not recording, so server busy. Oh that. Microsoft file them nothing up. Everybody I use Microsoft now. All right. So potassium dichromate here. All right, so you add it. All right, and then now it forms. All right, so it's gonna form. All right, or as Deborah said, it's also called a thing with chemistry now. Another thing, chemistry full of name, I don't know. If you can know names well, you would do it at chemistry. Chemistry is all about naming, And it's just weird because the names of things come from some little incident. It's like a beer inside joke, make a lot of these names. I'm wondering, all right, so fine. The alkenes, for example, they weren't always called alkenes, or the alkenes weren't always called alkenes. The name that they had before was actually better. If you learn chemistry back in the 50s, maybe a lot of your parents weren't even born then, but then in the 50s, alkenes were taught as paraffins. And they changed the name for some reason. They think that alkenes sound better. Say, all right. Alkenes were called olefins. So, but then why it was called that was that in those days, students would do a subject called Latin. Now, them claims that nowadays Latin is a dead language. But because students did Latin now, when you did any other subject like law or even sociology or biophysics, chemistry, right? Hold on. And you did those subjects. What would happen was that you would see a new word and you would know what it means because you'd learn in a Latin class, say the word para means without. So you say paraffin in chemistry, you're gonna say, oh, without something. Fin comes from the word finity, which means to continue. So paraffin means a compound that doesn't want to continue or without continuing. So what it means now that's that the paraffins did not want to react. which makes sense because when you talk about alkane, there's no root word in alkane where make you know how it going to behave. You know, so that's the situation. So it changed. So I'm saying inside jokes and all that sort of thing, and people say call it this. But what were you saying, Janari?
I was saying that you said Latin was dead, sir.
Yeah, them say that Latin is a dead language.
Well, English came from Latin. That's what they say, sir.
Yeah, they will say that.
Not
But
say that, sir. It was proven.
well,
Scientifically.
that is true, and it's a fact. I agree. But they will say that no. But you know, yeah, that's just what people say, really. Scholars have other views too. But then let's not get into the linguistic argument. We're just saying, all right, some words just should mean what they say more. Or say what they mean more. All right. So all right, guys. So this is the important thing. Alcohols will be oxidized into alkanoic acids. All right, of course, as Deborah was hinting at, if this reaction don't quite work, or when the reaction is halfway there, all right, then it forms something in between, but then that's not our concern. So of course, that in between compound is called the aldehydes. All right, so any questions here, guys?
No.
All right, so going back. So then we know say this compound then will be what? What type of compound would E be? Class? What type of compound would E be?
It's you want us to name it, sir?
Yes, because we will see alcohols with D. So what type of compound? And not asking for the name of the compound. Why people misinterpreting the question? What type of compound would E be?
It's an alcohol. Which one?
The question sure you said D convert to E. Right? They not give you them only to say D is an alcohol. Right? And it form another compound E after you add potassium dichromate to this. So I'm asking you now, what type of compound is E? All right, figure it out next class. All right.
Unsaturated.
No, I'm not gone. Now work out. All right. See you guys next class on a head mashup. So I'm gonna go over it and figure it out and text the answer in the group. All right. So I'll see you guys when Wednesday. We'll continue this. All right. Enjoy your evening.